Okay, so in this problem, we are told that this quadratic x squared plus px plus q is a factor of the cubic x cubed plus ax squared plus b. And then we're asked to show what you see here on the right-hand side, that b equals q times a minus p, the q equals p times p minus a, and finally that q squared plus bp is equal to 0. So my attack here, and the way I'm going to go about this is I'm going to, again, divide in this quadratic into this cubic, knowing that whatever remainder I get in a, b, p, and q, that will be equal to 0. Okay, so starting off, the x squared goes into x cubed, x times, we have an x times x squared is x cubed, x times px is px squared, and then finally x times q is qx. And then we'll subtract 0. Ax squared minus px squared. Well, that is ax squared minus px. That's a minus px squared. So I'm going to just write a minus p x squared. So that is ax squared minus px squared, just factoring out the x squared out of both those terms. And then finally, I have 0x minus qx. 0x minus qx, so that is negative qx. Negative qx. And then I'm going to bring down my last term, which is this plus b, so I'll put here plus b. All right, we ask ourselves, what do we multiply x squared by to get a minus p x squared? And of course the answer will be the coefficient a minus p. So I'll have here, this is plus a minus p. I felt like maybe I just put parentheses around that to remember that that is my entire coefficient on my x squared term. A minus p x squared is a minus p x squared. Then I have a minus p times px, so that is p times a minus p x. So I'll write that as p times, p times a minus p x. We'll put those two together. And then finally, I have a minus p times q. So that is q, that is plus q on a minus p. I could probably gather up here a little bit in this line here. I could, for example, I could distribute if I like. At the very least, I think I will distribute this one right here. And so that will give me a minus p x squared. That's going to stay the same. I'm not subtracting it, just tidying it up a little bit. That is plus ap minus p squared. When I distribute that p, I get ap minus p squared. P times minus p is minus p squared. And that is times x plus b, so I'm sorry, plus q on a minus p. I'm going to leave that as just q on a minus p. And now I will subtract, remembering that I'm subtracting this line here, which is the same as this line. So this line here from this line here. Okay, so I'm going to subtract. So that is minus parentheses. What I'm going to do is I'm just going to erase this line just so that I can see a little bit more clearly. Subtracting, I get a minus px squared minus a minus px squared. Well, of course, that's 0x squared, right? So I'm going to get 0 there, 0x squared. Those two will cancel. Then I will have negative qx. Of negative qx, that's this one, minus all of this. So ap minus p squared x. So minus ap minus p squared x. And I will factor out an x here out of those two in a minute. And then I have, as my final term here, I have b minus q on a minus p. So b minus q a minus p. Probably one last thing to do is, as I say, I have here an x term, here an x term. So I'm going to combine those together. So I will have, on x, I will have negative q minus, I will distribute this minus ap. Then distributing this minus in here, I get plus p squared. Plus p squared, and that's all on x. So minus, factoring out the x, I get and distributing. So I factor out my x out of this term and out of this term, and then I will distribute this minus in here into these parentheses. And then finally, plus b minus q on a minus p. And that's it. That is my remainder. That is what is left over. I remember that because it is a factor, this here is my coefficient of my x. This is equal to 0. And this here, my constant term, this here is also equal to 0 again, because we are told that that quadratic x squared was originally is a factor of that cube. So I can set up then two equations. Minus q minus ap plus p squared. That is equal to 0. One equation. And b minus q on a minus p. That is equal to 0. All right, so those are my two equations. Now it remains just to look at what am I asked to prove and see if I can go about proving it. Well, the first thing I'm asked to prove is that b equals q on a minus p. Well, that is relatively straightforward, because if I just look here, all I have to do is take this negative q on a minus p and bring it over to the other side, and I will find then that b equals positive q a minus p. Just bringing that to the other side, and so that is part 1 complete. I'll just highlight that because that is the first part of my problem. Complete. B equals q on a minus p. Done. Second part, we want to show that q is equal to p on p minus a. So if I look over here, perhaps to this side, I've got q's, I've got a's and p. So what I'll do is I'll add q to both sides, and I will have q equals p squared minus ap. And so I just added q to both sides and just rearrange it. And so I have a p squared, I have a negative ap, and what can I do? I can factor out on the right-hand side of that equation a p. So that gives me p on 1 minus a. Is that what I'm asked to show? No, I need to show, I'm sorry, pardon me, no, 1 minus a. You factor out a p out of p squared, you're left with p minus a. So q is equal to, factoring out a p out of p squared, I'm left with p. Factoring out a p out of ap, I'm left with a. So q equals p on p minus a, and that's the second part complete. And so I will highlight that. That's the second part of your problem. And then finally, the last thing we're asked to show is that q squared plus b times p equals 0. So the way I would go, but what I notice about that last part is that there's no a. There's no a here. And so what I think I will need to do is I will rearrange here in terms of maybe I'll solve for my a on one side. Sorry, on one side here, and then I'll substitute it into the other equation. So either I solve for a here and substitute in this side, or the vice versa. Yes, I think that is the way I'm going to go about it. So I will say then that solving this, I have q equals, again, p squared minus ap. I will rearrange this, add ap to both sides, and so I get ap equals p squared minus q, right? Adding ap to both sides and subtracting q. And then finally, dividing both sides by p, I get that a equals p squared minus q all over p. So that's my value for a. And what I can do is I can take this value for a right here. I'm going to substitute it in to this equation right there for a. That's what I'm going to do. So I will have then b is equal to q on p squared minus q all over p minus p. And so what I've gained is I know a's now in my equation. I will combine. I will get b is equal to q times I have two fractions. I want it to be 1, so a common denominator here is p. I will get p squared minus q minus 1. You could think of this here as p all over 1. So 1 goes into p times p is p squared. And so I have b is q on, and inside the parentheses, I have, in my denominator, I have p, and then in my numerator, I have p squared minus q minus p squared, but my p squares will cancel, and I'll be left with minus q. And so distributing now my q, I have b, I'll go down to my next line, b is equal to, distributing my q in here, I get negative q squared, q times q squared, all over p. So b is equal to negative q squared all over p. If I bring that term to the other side, I just remind myself what I need to show. That q squared plus bp is 0. So if I cross multiply, I will get that b times p, cross multiplying b all over 1, is equal to negative q squared. And then adding q squared to the left-hand side, I get that q squared plus bp is equal to 0. Q squared plus bp is equal to 0. Yes, perfect. So that's what we're asked to show. And that is at least one way we can go about it. So just using substitution, and there you go. That's how we show that we've proved what we've set out to prove using, again, that division method. All right, thank you very much.